last year it was two lines graphed on the same set of axes. Now it's two equations graphed on the same set of axes. Because there's two? I don't know. It could be a pair. I don't know. What makes a set a set? I be not your English teacher. It was tempting there. Just recall, just putting these words back in your head, there's three ways to solve. We did it by graphing, we did it by substitution, we did it by elimination, which I'll review them in a second. And so what's new this year is we're now looking at what's called linear quadratic or quadratic quadratic. All you did last year was linear, so two lines crossing. Now we're going to do parabolas and lines and parabolas with parabolas. Go back in your head to grade 10 when you did the lines and lines. How many different solutions were possible? So you could have one solution if they crossed once, but there was two other cases you should have looked at last year. They don't cross at all, and what kind of lines do not cross at all? Parallel. And then there was a third case, so it either had one solution, no solutions, or infinite. And what kind of lines have infinite? Is when they're right on top. So do you kind of remember that idea? Okay, so same things now, the number of solutions for linear quadratic system. What do you think? How many times could a line and a parabola cross? Could cross 0 times. What would it look like if they didn't cross at all? But one's a parabola, one's a line. So any particular line, where would the parabola have to be so that they do not cross? Above. It'd have to be up here somewhere. So you could have no solutions. What's another situation? How could you have one solution? What would the graph look like? Okay, so parabola. And where does the line have to be? And touching it specifically where? Right on the vertex? So you could have no solutions, you could have one solution. What's the most common number of solutions? 2. What would it look like to have 2 solutions? Goes through it twice. Those are the only 3 cases possible. It's either going to be once, 0, or twice. Can't have 3, can't have less than none, can't have infinite because they can't lie on top of each other, can't be parallel. It doesn't work that way. Okay, what about quad quad? So let's just highlight this was linear quadratic, which means one line, one parabola. What does a quad quad system mean? 2 parabolas, okay? So what is all the different possibilities that 2 parabolas can intersect each other? Okay, how would it be 0? What would they look like to not cross at all? One's going up and the other one's going down. What might case number 2 be? One solution. What would they look like if it's one solution? The vertex are touching, so I could say that they're kissing each other. It was the video following the one that we watched. That means you're very auditory. What might the third situation be? And what would it look like if they cross twice? They overlap. So one goes up, one goes down. The rest they use it is just solving the system. So we're going to do the exact same methods that you did last year. We're going to do graphing today, and then we'll do elimination and substitution tomorrow. So So same methods as grade 10, nothing has changed. I'm just making one or both of the parabolas quadratic. Well, we're going to do graphing by hand, and then we'll do graphing with the technology. Okay. What do you think? How'd you do it last year? You graphed it, and then? Drew dots, yes, and looked at it, and what were you looking for? What do we call those? More specific? Intersection points. Graph each parabola. And mark the intersection points. How many methods are there for graphing a parabola? 2. What's the first method? Vertex, direction, width. Second method was? Vertex. Which method would you like to pick? Okay. What do we do with this guy, the first one? Okay, and complete the square. Okay, so walk me through completing the square. I've said nothing so far. Do you see how everything in this course kind of flows along and we keep using all the old stuff? Right, so we did this in Unit 4, but it's coming back in Unit 5. Parabolas are the thing this year. We're going to be sick of parabolas by the time we're done. And they come back next year in 4 different units. It does. Kind of nice that it fits perfectly. Now we have to graph the other one. Okay, this is a line, so we're not completing the square, we're not doing vertex, it's a line. How do we graph a line? Y-intercept at -2. Up 2 over 1, confirm. Because there's no squared, so I know that it's a linear function, so it's y equals mx plus b. So we start with the b and then count the slope. Remember, on a test or a quiz, to use a ruler or a straight edge. If you have a jagged, nasty line, I'm taking marks off. We are not barbarians. Intercepts are always coordinate pairs, because it's a particular point that it crosses. Comma of -2, -6. And comma 1, 0. So this is the solution to our system. That's the only 2 points that satisfy both the parabola and the line. Exactly the same method you did with lines, it's just one of them now is a parabola. How I got these? Yeah. I just looked at these 2 points. So where they physically cross. Hayden. Well, why don't we go on to question number 2 that says using the calculator? That was a very good segue. Let's do it first, then we'll write the method after, so just focus on your calc for now. Okie doke. What do you think we do? I don't know. It's a good question. Where do we put the second one?
On the y2, yes, there.
Wow. Oh, negative 0.5, thank you. We don't want to go to graph. We always go to zoom. We want to pick standard so we all have the exact same graph. Ooh, it is kind of pretty.
Then we go second calc, right?
Then we go second calc. What in there looks like something we might use for this. Number 5. Now, because there's 2, you just need to be closer to 1. I'm going to find them in order. So I'm just moving my arrow till I'm closer to the one on the left. This isn't a left-bound, right-bound thing like before. You just need to be physically close. It's saying, is this the first curve? Well, we only have 2 curves, so we're going to hit enter. What the spider did was jump to the second graph. It's asking, is this the second curve? I'm going to hit enter. It always says guess, which I have no idea what means. I'm going to hit enter the third time. So we went second function calc, intersection, and then I just move closer to the left one, enter, enter, enter. Second function calc, number 5, move close to the left one, enter, enter, enter. The reason it asks first curve, second curve is sometimes you can have 4 or 5 or 6 different curves and you're trying to find the intersection of 2 particular ones. So it's not as much work when we only have 2, but that's why. Jot that one down. I just went closer to the left one. So I just moved my arrow keys till I was physically by the left one.
Is it on the red or like?
It doesn't matter. How do I find the other one? Because I know it crosses twice. Do the same thing, so second calc, intersect, and now I'm just going to move closer to the other one. Again, it's not a right-bound, left-bound thing. You just have to be physically closer to it. First curve, yes. Second curve, yes. Guess, I don't know what that means. Bam, there's the second answer. Jot that one down as well. But it's symmetric, right? So it makes sense that it would be because the one is right around the y-axis. Yep. 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 So closer to one. Yep. Closer to the other one. Yep. Now, if it's a calculator question and it says solve this by graphing, you can't just put down the answers. What do you think you need to show me? You need to do a little sketch of the graph, and you need to mark the intersection points. So that's how you're going to get full marks. So a quick sketch is not an exact. It's just, ooh, this one's like this. Ooh, this one's like that. Okay, that's a quick sketch of the graph. So you don't have to graph the parabola by hand. It's not what we're asking. We're just saying, what did you see on your calculator? And then we want to know, what did you find? So marking it tells me you did the intersect. If you were to mark the intercepts, I would know you found x-intercepts. If you were to mark y-intercept, I know you would find y. If you would have marked the max or min. So marking it just tells me what you did on your calculator, rather than having to type in every single key that you pressed. And then the last would be to get the answers, which I didn't write down the first one, but you did. That's this one. Well, what was the first one? And 1.6. And then positive 2.19, 1.6. That's full marks for a calculator question. You get 1 for the graph, 1 for marking what you found. The last mark would be for stating the answer. So they're typically 3 marks questions. If you just write down the answers, how much are you getting out of 3? 1 out of 3, right? Unless they're wrong. Of course, you have to have the graph, you have to mark the points, and give me the answers. Okay, what did we do? But I did something before that, because how did I actually get the graph to appear? Zoom. And I picked number 6. What did we pick in second function calc? Number 5. And then we hit enter 3 times. And then I'll put move cursor and repeat. Cursor or cursor? Cursor? Cursor. I don't know, they both look right. With an O? So if you weren't aware, just like last year, your exam has 2 sections to it, a calculator and a non-calculator. This is the method for non-calc. This would be the method for calculator. So if it's the calculator section, don't draw it by hand. Let the calculator do the work for you, because typically they're nasty numbers like this. We're not going to give you nasty numbers on the non-calc section. So if it's a calc one, use your calc. Let it do the work for you. Wait. It's okay. Go ahead and try number 3. Use your calculator. So mine kind of looks like this. Same graph. Okay, so second calc, number 5, enter, enter. Nothing happened. Oh my God, I got an error. What does that mean? Yeah, well, you can look right at the graph. What do you see here? It doesn't cross. So what's the answer? No solutions. NA does not exist. Don't just leave it blank. Blank tells me you didn't know what to do. So I would probably put no solutions. So there is no point that's going to satisfy that parabola and that line. Please don't come and tell me your calculator's broken. Okay, no, it's not broken. Let's practice one without the calc, so we'll do a quad-quad. Thoughts? So you know enough now is that you're probably happy when you see this form like I am. You're like, yes, no completing the square, no work to do. Vertex for the first one. Direction. Width. And we'll do the second one at the same time. I'm going to switch colors. So 3, 6, over 1, up 1, over 1, up 3. Dotted or solid? Trick question, it's not an inequality. Shading inside or outside? Trick question, not an inequality. Five, 2, over 1, up 1, over 1, up 3, over 1, up 5. Oh, there we go. Now what? Except they're the same width, so they're going to go up almost parallel to each other. Because the widths are the same. If the widths were opposite, they would cross way up top somewhere, but this one they won't. What do I have to do now? Yeah, so mark the point so that I know what you're trying to find. And the marking just helps me, because sometimes if you mark the wrong point, but your wrong point is off of your incorrect graph, then it just helps me to know what you're doing. And then we just state the point. What's the point of intersection? Questions?
Like, all of my, I don't know, I'm not a very good artist, so, like, all of my dots, like, never line up.
So if your graph was drawn poorly, but your point showed me the intersection point, I'm okay with that. Like if you had some kind of decimal super close, I'm okay with that. Hayden. Yeah, if it's a non-calc question, it's never going to be kind of nasty like the calculator ones. We'll stop there just to peek what's coming up, because it's the end of the unit, is we'll go into algebra tomorrow. So I've put down the steps for substitution and elimination. If you can just read through them before tomorrow to kind of put it back in your head, it'll go faster. And then that's it. That's the end of unit 5 after that. Sorry?